This module is about the free function. It's actually quite simple. Whenever you allocate memory from the operating system, from the heap, using malloc or any of the other functions that give you memory, and there are some others, we'll be looking at them in this chapter, as a matter of habit, you should free that memory. In other words, you should give it back to the operating system and say, okay, I've finished with this memory, I now no longer need it. The operating system will put it back into the pool of free memory and make it available to other programs that run malloc or something similar. I can't stress enough that you must get into the habit of doing this. Every time, I do it like this, this is how I personally do it. Every time I write a call to malloc, I write a call to free, just so that I make sure that I'm freeing up the memory that I'm allocating. Now, this is what it looks like. Let's say you've got a pointer and you malloc 100 bytes. At some point after that, you must free up that memory. Now, you can get away with it to a certain extent in that the operating system, I mentioned this before, the operating system will automatically free up any memory that you grabbed from the heap. It will be freed at the end of the program. When the program terminates, you obviously don't need any of that memory anymore, so all of it will be put back into the free memory area of the operating system. So you can rely on that if you want to, but I would suggest that you don't. As a matter of habit, free anything that you malloc. Just get into the habit of doing that, because there will be one day when you forget to do it and you keep on mallocing and mallocing and mallocing. You might have malloc sitting inside a loop somewhere, or you might have it sitting inside a function that gets called many, many times. And when you forget to free it, you end up running out of memory, and you can actually run out of memory in your entire operating system. I've seen it happen many times, far too many times. It's one of the great bugs of the C programming language it's one of the great bugs that you can create using the C programming language. Another way that you can create a bug in your program is attempting to free a memory area that was not allocated with malloc. In other words, that the first of those two statements there, if that didn't get run, someone might still try and free up the pointer. Now I've done that. I've done it not quite as often as I've done the other bugs that you can do with malloc, but I've still done it. Maybe you malloc 10 things and you try and free 11 of them. I've seen that. Anyway, try and get into the habit of matching one for one all the mallocs with all the frees. Anyway, let's go and have a look at the free function. Okay, here's free.c. Now this is exactly that same program, the malloc.c, that you had a moment ago. And now I'm going to add the corresponding code to free up this particular malloc. Now, I could do it right down here just before we end the program. The best place to do it is immediately after you no longer need the memory anymore, which is in fact right here. So here is where I could write the code. And what I'd like to do is to write it like this. I'd like to write a little function called free the memory, and I'm going to pass it one parameter, which is the integers, like that. And all I want the function to do, what was it called? Free memory, and it's going to take a pointer, an int star, and what's it going to do? Okay, well it's simply going to call free, like this, free pointer. Now, why have I done it like that? Why didn't I simply just take that line and put it just down here? Say free the integers. Well, I only did it just to demonstrate to you that it is possible to pass these values around, pass these memory areas around, and use them from place to place. In fact, I'll just slightly rewrite this program now. I'll just pause this recording myself. You won't see a pause, and I'll just rewrite this. Okay, hey presto, this is still free.c, but I've rewritten it a bit. I've just basically done a bit of cutting and pasting. I've created 3 functions now, a grand total of 3. I've got one called allocate the memory, then one called use the memory, and then one called free the memory. And allocate the memory will actually allocate the memory, do the error checking, and then pass back to me as the return value the memory that it created. or the address of, I should say, the memory it created, and I'll stick that in the same place in integers. Then I will pass that in to a function that's going to use it, and then I'll pass that into a function that's going to free it. Now, why have I done it this way? I've done it this way because this is the way it is usually done in C programming. Pointers that point to bits of allocated memory, those pointers get passed around all over the place. They get passed over here where they get used for this, they get passed over there where they get used for something else, and then finally they get passed to some function where they inevitably get freed. Well, they don't always have to get passed to a function where they can get freed, but that happens quite often. This is how I want you to treat this whole way of viewing memory now. You can create it when you need it, pass it around from function to function. I'm going to use it here, now I'm going to use it there, and finally when you're finished with it you can free it. You don't have to free it at the end of the program. Notice that we've still got a couple of things that we do before the program ends, and the freeing is not the last thing that happens. Anyway, let's have a look at them. Free the memory is still the same. Now let's have a look at the other two. Allocate the memory. Notice that allocate the memory returns a pointer to an integer. That's its return type. That's the type of that function. And we'll declare an integer pointer here. We'll just call it PTR. We'll set that to be to the malloc. Notice that the required now is now a hash define. The number of integers required is now just defined here. If I want to change it, I can just change it once at the top of the program. And check that if that failed, and if it does fail, then we simply exit the program, and if it doesn't fail, then we return the pointer that we created, or rather we return the address that we created. Notice that as soon as I call this return statement, the address in pointer gets passed back to main, and as soon as that happens, pointer itself, pointer the stack variable right here, which is part of this function, pointer gets destroyed. However, the memory that it points to does not get destroyed. In other words, the address is still a valid address, even though the pointer that points to it has now gone. Now, if I didn't do this is just a little aside here, if I didn't have this line, then look at this function. We allocate some memory, and then we don't do anything with it. In other words, the only thing that is ever keeping track of where that memory is destroyed. So we no longer have the address of this memory anymore. That's another trap about using dynamic memory. Always keep a pointer somewhere that points to it. If you don't, you can never use it again, and you certainly can't free it. So anyway, we do need that line. Anyway, the use the memory part of it is exactly the same as before. It's just do a couple of for loops, read them in, print them out, and that's about it. But now you can see that my main is really quite straightforward. If you have a look at the main, you can really see what the program's doing. Allocate a bunch of memory, then use it for something, and then free it up. And that is the way most dynamic memory programs work. Let's check that it works. Compiles and runs. Okay, no errors, and run, and it's working. Okay, great. So I suggest that you take a bit of time and have a look at this example, because this is a very standard procedure for using pointers, for using dynamic memory, and for treating pointers as arrays.